So for those who want to get the question clearly, that they want to see the questions, so these are the questions, the one we just solved. I mean the one for the coefficient of restitution and the impulse. So this is the main question. So for those who want to extract the question, for those who want to get the question clearly, so you can read the question A clearly, and then the solution provided was the one I've already sent, through the channel. So this is it. So you can read it very well, read it word for word, and compare it with what we did in the worksheet. So that's it. Read it very well and read it line by line. So word for word, you can see that it's correlated with what we did recently based on coefficient of restitution. Another thing I want to add to this is what when the coefficient of restitution is one, you get it now, is perfectly elastic, or greater than one is perfectly elastic. So if it is less than one, it's perfectly inelastic. You get it now. So these are the conditions. You can ask that what are the conditions for this kind of restitution, that is the collision A will be perfectly inelastic since it is less than one. But if it is equals to one, it is perfectly elastic. But this one is perfectly inelastic. You get it now. So if it is equals to one or more than one, you get it now. So it is perfectly elastic in that way. Perfectly elastic in that way. So then from the basic knowledge you have, in collision, then in impulse as change in momentum, from the Newton's second law of motion. That is where we derive this formula. Impulses or change in momentum. So if you can able to get that, so you'll be at least we see through. So, but the only difference in that second law is that force is not, that impulse is force times time. Then you equate it to what change in momentum. So that one is equivalent to each other. So we derive that one from the second law of motion. And then another thing I want to say is that coefficient of restriction, it really works on the Newton's law of impact. So the physicists, they count it as the Newton's fourth law of motion. So that is the law of impact. It deals with collision. It deals with impact. Impact means collision. That's the meaning of impact. So that is where we derive this kind of formula. It's from the Newton's fourth law of motion. We can call it the fourth law. We can call it the law of impact. So it means the same thing.